Okay, in this class I just want to look at another example of a question. This is also taken from an old Leaving Cert ordinary level paper from 2009. This is a question on direct collisions. We'll be answering it in the same way as we did the last example. We'll be using Newton's experimental law of restitution and the principle of conservation of linear momentum to answer the question. So what's been asked is to find the speed of A and the speed of B after collision. So what's been given, we've got a smooth sphere A, there it is on the left, mass 5, colliding directly with another smooth sphere B of mass 2 on the right, and a smooth horizontal table. Before impact, A and B are moving in opposite directions. That's going to be important. They're moving in opposite directions. So what's going to be, different about this from the last example, they're moving opposite directions. If I define this as being a right positive system, well, the 2 kilogram particle here will be moving to the left, which will mean its velocity will be negative. So their speeds are 3 and 5 meters per second respectively. The coefficient of the restitution for the collisions is 3/4. That tells me about bounciness, how bouncy the collision is. Find the speed of A and the speed of B after collision. Okay. The big thing that's different from the last example is they're moving in opposite directions. That's really important. I'm going to answer all these questions in more or less the same way. And I'm going to start off by drawing a little table out. I'm going to mention what the initial velocities are, what the mass of each object are, what the final velocities are. The objects are just called A and B, so let me put their names down there. So initial velocity, object A, what's it doing? Well, it's moving to the right at 3 meters per second, so its velocity will be positive. Its initial velocity will be positive, 3 meters per second. Notice its mass also is 5, so that can go in there as well. Object B, this is where most people will go wrong. Object B is moving to the left at 5 meters per second, so its velocity is negative 5. Why negative? Because I've defined the coordinate system to be right positive. I could have defined it to be left positive, in which case the velocity of A would be negative and the velocity of B would be positive. But in general, we tend to go with right positive. The mass of that second particle B is 2. And the final velocities, well, that's the things we're looking for. From here on in, it's exactly the same as the last. And if you remember the last example we looked at, we used Newton's experimental law of restitution to come up with one equation in x and y. We'll use the principle of conservation of linear momentum to come up with a second equation in x and y, and then we'll solve those equations simultaneously. So we have all the key details here. Also remember that the coefficient of restitution is 3/4. So we're going to start looking at this. Ultimately, I'm trying to find x and y. Now, x and y will be velocities, so I have to interpret the velocities into speeds. And then we'll go back and think about what that means, physically. What does all that mean? So the first thing I'm going to use is Newton's experimental law of restitution. Notice I'm always giving it a title. And Newton's experimental law of restitution is in your formula and tables booklet. It's up on page 51, I think. So, and Newton's experimental law of restitution says V1 minus 2 is equal to negative E times U1 minus U2. Okay, where V and U are velocities as opposed to speeds. So we're talking about velocities. So we're talking about the relative velocity an instant after impact is equal to negative E times the relative velocity an instant before impact. So plugging everything in here, final velocity of particle 1 is x. Final velocity of particle 2 is y, so we get x minus y equals negative E, well, that's negative 3/4 times U1, the initial velocity of particle 1, which is 3. Subtract U2, which is negative 5. So this is what we have at this stage. Okay, I'm just going to multiply everything out. We're going to get x minus 1 equals negative 3/4 3 subtract negative 5, subtracting negative is the equivalent of adding. So we're talking about 8 subtracting a negative is the same as adding a positive. And then a nice bit of cancellation over on the right hand side to get rid of that fraction. That's going to be negative 6. Okay, and I'm going to just call that equation 1, and I'm going to keep it until I have a second equation. There's Newton's experimental law. The second principle we'll be using is the principle of conservation of linear momentum. Also in your formula and tables booklets, let me just write this up here on page 51. And it says this, it says m1u1 plus m2u2 is equal to m1v1 plus m2v2. So the total momentum before impact and instant before impact is equal to the total momentum and instant after impact. And again, we have to be careful with the negative sign. That has to be included. We're talking about velocities here, not necessarily speeds. Velocities. So m1, u1. So m1, that's the mass of the first object, 5 times its initial velocity, 3, plus m2, well that's 2, times its initial velocity, that's negative 5, is equal to m1, again 5, times its final velocity, we're just calling that x, we don't know what it is yet, plus m2, 2, times its final velocity, y. Okay, and then we're just going to simplify that. Simplifying that equation, we're going to get 15, and that's going to be minus 10. So we're going to get 5 over here on the left hand side is equal to 5x plus 2y, and we're going to keep that. That's equation number 2, and now we're going to solve these two things simultaneously. I'm noticing here I've got 2 y's in here, but I've only got 1 y in here, negative 1 y. So if I double equation 1 using the multiplication property, as long as both sides are multiplied by the same quantity, then the two sides will remain equal. So I'm going to double equation 1, I'm going to maintain equation 2 exactly as it's written. So we're going to solve here. So equation 1, I'm going to take it and I'm going to double it. And actually let me write down equation 2 first. I'm going to write down equation 2 first, and then I'm going to double equation 1. Okay. So equation 2 just says, and I'm going to just write it the other way around, 5x plus 2y equals 5. And equation 1, I'm just doubling everything, double x, 2x, double negative y, negative 2y, double negative 6, negative 12. And now we're just solving. We're solving from here. Okay, so you can see the numbers of y's are the same in both equations. So I'm going to use either the addition or subtraction property, which will work. Well, it's the addition property here because adding 2y and negative 2y will give me 0y. So we're adding equation 2 and equation 1 here. So we're adding these things using the addition property of equations, which says if equal quantities are added to both sides of an equation, then the two sides will remain equal. The 5x added to 2x is 7x. The 2 y's will cancel. 5 subtract 12, that's negative 7. Okay, and pretty straightforward there to solve. For x must be negative 1. We're dividing on both sides by 7 there. How do we solve for y? Well, we go back to equation 1. Okay, and we just make y the subject of the formula. If we look at equation 1 here and make y the subject of that formula, adding y to both sides, y would have to equal to x plus 6, adding 6 on both sides as well. Adding 6 to both sides, x plus 6, adding y to both sides equals y. So we know that y is equal to x plus 6. So I'm going to write down, and we know that y is equal to x plus 6. Therefore, y is equal to, well, we know x is negative 1, negative 1 plus 6, which is 5. Okay, notice x negative, y positive. X was the velocity of particle A. So the velocity of particle A after impact is -1 meters per second. And the velocity of particle B after impact is equal to +5 meters per second. Okay, so just one final thing, let's just think about what that means. So on my coordinate system, I'm going to scroll back up and look at my coordinate system now in a second. What does a velocity of -1 mean, and what does a velocity of +5 mean? So in my coordinate system, which is right positive, a velocity of -1 would mean it's moving to the left at 1 meter per second. A velocity of +5 would mean it's moving to the right at 5 meters per second. What are we asked to find? Well, actually, we're not asked to find velocities at all. We're asked to find the speeds. So the speed of A is equal to, well, what's A doing? The velocity of A is -1. That means it's moving at 1 meters per second to the left. So its speed is just 1 meter per second. And the speed of B, well, it's moving at 5 meters per second to the right. So that's just going to be 5 meters per second. So notice it didn't say find their velocities after impact. It said find their speeds. So the speed of A is 1 meter per second. Speed of B is 5 meters per second. The negative here and the positive here, that's telling me about direction. That's to the left, that's to the right, because I've defined my coordinate system to be right positive. Okay, so get practicing on those things. You know, we're in section, I think, 7B at this stage. Okay, 7B. Okay, practice.